A piece of wood of mass 0.03 kilograms is dropped from the top of a 100-meter height building. At the same time, a bullet of mass 0.02 kilograms is fired vertically upwards, with a velocity 100 meters per second from the ground. The bullet gets embedded in the wood. Then the maximum height to which the combined system reaches above the top of the building before falling below is GE equals 10 meter per second square. To solve this problem, we will analyze it in two stages. The collision. When the bullet embeds itself in the wood, we can use the conservation of momentum to determine the velocity of the combined system just after the collision. The motion of the combined system. Once the bullet and wood are combined, we will calculate the maximum height the system reaches. Step-by-step solution. Step 1. Initial situation and collision. Mass of the wood, M1 equals 0.03 kilograms. Mass of the bullet, M2 equals 0.02 kilograms. Velocity of the bullet, V2 equals 100 meters per second. Velocity of the wood before collision. Since the wood is dropped from the top of the building, we can calculate its velocity when it reaches the point where the bullet hits it, using the equation of motion. V1 is equal to square root of 2gh, where h is equal to 100 meters, g is equal to 10 meters per second square. By substituting the values of h and g, we get V1 is equal to 44.72 meter per second. Since the wood is falling, its velocity is negative. Therefore, V1 is equal to minus 44.72 meter per second. Step 2. Conservation of momentum during collision. The bullet gets embedded in the wood, so after the collision, the two masses move together as a single system. We apply conservation of momentum to find the velocity of the combined system just after the collision. M1 into V1 plus M2 into V2 is equal to M1 plus M2 into VI final. Substituting the values, V final is equal to 13.17 meter per second. Therefore, the velocity of the combined system just after the collision is 13.17 meters per second upwards. Step 3. Maximum height reached after collision. After the collision, the combined system moves upwards with an initial velocity of 13.17 meter per second and decelerates under the influence of gravity. The maximum height is reached when the velocity becomes zero. Using the kinematic equation, V final square is equal to V initial square minus 2g into h max. At maximum height, V final is equal to 0. H maximum value is equal to 8.675 meters. Step 4. Total height. Above the ground, the maximum height above the top of the building is 8.675 meters. So, the combined system reaches a maximum height of 100 plus 8.675 equals 108.675 meters above the ground. But the question asks for the height above the top of the building. Final answer. The maximum height above the top of the building is approximately 8.68 meters.